In this video, I'd like to talk about how to multiply powers. So basically, you can see in this example problem, we have two different exponential terms that are multiplied together. And notice that these exponential terms have the same base. So what I mean by base is the bottom number, the 3 in this case, where the 4 and the 2 are the exponents. So how do we handle this situation where you have the same base, and let's say we have different exponents? So with the same base and different exponents. So this is our multiplying powers typical problem. And to solve a problem like this, we want to be able to rewrite this in the form of 2 to some power. And I'll just use the letter n to represent whatever that power is. And notice in this problem, to actually solve it, we'll need to rewrite this expression here in the form 3 to the n. So let's first consider this simpler example problem, though ultimately they're very similar. And to solve these problems, you need to think about what it means to raise something to an exponent. So think about 2 to the third power. And basically what this means is take this number, which we call the base. Let me just write that down so that you have that. So we have the base raised to the third power. So we're going to take this number and multiply it this many times. So take 2 and multiply it 3 different times. And 2 times 2 times 2 is going to be 8, since 2 times 2 is 4, and then times 2 again gives you 8. But I'm first just going to rewrite 2 to the third as 2 times 2 times 2. Now, we could actually multiply all this out, but for this particular problem, we're looking to just simplify the exponent. So I'm first rewriting 2 to the third is just 2 times 2 times 2. And then 2 to the fourth, we're going to take 2 and multiply it 4 times. So we'll rewrite that as 2 times 2 times 2 times 2. And now looking at this, since this is a product, these two parentheses are multiplied together. So in essence, you can really drop the parentheses if you want. But you can count. There are 1, 2, 3, 4, 5, 6, 7 of these 2's multiplied together. And we know if we multiply 2 by itself 7 times, that we could just rewrite that as 2 to the 7th power. So in this case, n would be 7. But notice the pattern here. Notice that effectively you just add the exponents. 3 plus 4 gives you 7. But I want you to understand it from these basic principles, rather than just memorizing the rule that you add the exponents. Because there's going to be different scenarios. In a later video, we'll look at what happens when you take 2 to the third and raise it to the 4th power. And you'll see that in this case, you'll end up multiplying the exponents together. But if you just memorize the rules, you tend to mix these two up. Or at least that's what students do. That's the most common mistakes that I see, is that when students memorize these rules rather than understanding it from basic principles, that they mix up the rules and when to apply it where. So it's better to understand it from basic principles, and that way you're much less likely to forget the rules or to mix it up with another rule. So with that in mind, let's look at this first example problem. And we have 3 to the 4th times 3 squared. And I'm going to rewrite this using our basic principles. So what does it mean to take 3 and raise it to the 4th power? Well, that's just 3 multiplied 4 different times. So 3 times 3 times 3 times 3. And then 3 squared is just 3 multiplied twice. So 3 times 3. And notice you have 6 of these 3's multiplied together. So we can rewrite this as 3 to the 6th. And that's what you'll put in the box up here, 3 to the 6th power. So in this case, n would be 6. And again, notice the pattern. If you just add the exponents, 4 and 2, you do get 6. So we can generalize this. But again, you don't want to just memorize the rule, but let's generalize it. If you have a to the x power and you multiply it by a to the y power, as long as these are the same base, then you just add the exponents. This will be a to the x plus y. But like I said, make sure you understand this from very basic principles before you just blindly memorize this rule. So let's try this problem now. We have 7 to the 8th. Let me rewrite that. 7 to the 8th equals 7 to the 8th times 7 to the x. So in this case, we need to figure out what x is. And this is a particularly tricky problem because we have 7 to the 8th here. So this side, this right side has to simplify to 7 to the 8th. But we already have a 7 to the 8th term right here. So the only way this side can simplify to 7 to the 8th is if this term right here was equal to 1, since 1 times anything is just itself. So let's think about this 7 to the x. What can we raise 7 to so that this simplifies to 1? And like I said, this is a fairly tricky one. And you have to know that when you raise any number to the 0 power, that it's always equal to 1. So if I take 112 and raise it to the 0, that's also 1. If I put 17 to the 0, that's also 1. So anything to the 0 power is equal to 1. And since we need this term right here, this 7 to the x term, to equal 1, we have to make x equal to 0. That's the only way that this will work. If x is any other number, this would not work. Now, another way to approach this problem is to just solve it like an equation. Since we want to get essentially this x term by itself, we need to get rid of this 7 to the 8th. And since 7 to the 8th is multiplied by 7 to the x, we can just divide each side by that to cancel it out. And something divided by itself, that's always just 1. So 7 to the 8th divided by 7 to the 8th is just 1. And you'll be able to cancel that out on both sides. So you just get 1 is 7 to the x, which is what we figured out by a slightly different method of reasoning. But to make this equal to 1, x has to be 0. So let's move on to another problem. So this one we have 11 to the x equals 11 to the 4th times 11 to the 5th. So this one's a little bit more straightforward, like our first example problems. Let me just rewrite it. So 11 to the x is 11 to the 4th times 11 to the 5th. And we essentially just want to simplify this right-hand side to be able to rewrite it as 11 to some power. And we could just apply our rule, but let's again use basic principles. We have 4 of these 11s multiplied together. So 11 times 11 times 11 times 11. And then here we have 5 of them multiplied together. And once you write it out in this expanded form, you can just count them. You have 9 of these 11s multiplied together, so we can rewrite this as 11 to the 9th. And comparing it to the other side of the equation, 11 to the x, you can see that x would have to be 9. So in the box up here, x would be 9. And let's look at another one. So we need to solve for x. And so we have x to the 9th equals 12 squared times 12 to the 7th. So let's first rewrite it. So x to the 9th is 12 squared times 12 to the 7th. So this one, it looks like we need to figure out what this base is, this x. And looking at the right-hand side, it looks like we can simplify this because they have the same base, so that means we can rewrite it with just one exponent. So 12 squared, remember, is just 12 times 12. So there's 2 12s multiplied together here, and here we have 7 12s multiplied together. So in total, there's 9 of these 12s that are multiplied together. So when we compare this to x to the 9th, notice they have the same exponent, an exponent of 9. And for these to be equal, their bases have to be equal. So in this case, x would have to be 12. So we can put the number 12 into the box. And we'll do one final problem here. So we need to simplify this expression and rewrite it in the form 4 to the n. So 4 to the 4th times 4 cubed. We have 4 of these 4s multiplied together. Remember, it's always the base multiplied that many times. And here we have 4 multiplied 3 times. So 4 times 4 times 4. And in total, you can see you have 7 of these. 4 here and 3 here. So 7 total. So we can rewrite this as 4 to the 7th power. So that's what you would put in the box up here.